I'm back. And what are we doing? Well, we added a scoreboard. Technically, it works. Although I think when we actually tested it, it was reversed, but we fixed it. I think one of the things I want to explore more are signals, right? So we're already using a signal here in this node to receive a message that something has entered the goalpost. I want to also maybe make a custom signal that indicates that the player or AI has scored. Does that make sense to do? I mean, we do. Well, no, because we do have a signal now for entering the goalpost, but technically, I mean, in practice, in this situation, really the only thing that's entering it is the ball, except because there is some overlap. Technically, the wall sometimes enters it when the scene loads. The wall does enter it too. But I think, the whole point of this is not to like, oh, I'm gonna make an awesome Pong game and ship it. It's to practice. So in that vein, let's go over to the project and let's figure out. So we have signals. Do we on the scoreboard? Let's attach a script. Yeah, sure. Okay, so we have our scoreboard.gd file that extends node2d. It's not going to have any kind of process. Can we? How do we define a signal? This script will handle scoring events and updating the scoreboard. Yep. Now it's repeating itself. So this is where I have to Google. Godot signals. Although I might be. Let me check my. Well, it's right there. It's fine. I was gonna say check the game dev resources because I do have links to some various documentation, but I guess not for signals. I should have the cheat sheet open though. It's so bright. It's like, hey, here's how you define a variable. This is a good reminder that I could have looked at earlier. Constants, scope, etc. This is, normally cheat sheets are like a page. I might have to make like a more abbreviated, like single page cheat sheet for me. Or, probably when I get to that point, I probably won't need it. So the Godot docs for signals. They are messages that nodes emit when something specific happens to them. Other nodes can connect to that signal. It's a delegation mechanism. So what I was saying before the break is like, we don't want to have one node, and we've done this a couple of places, where one node has to know about other specific nodes, and we hard code the relationships between them, right? So like when we're in like player, what was the example? So the AI has to know, hey, the ball is this thing that's over here, right? To be able to find its position. One of the things I was thinking about ways of approaching doing this today was making it so that the ball would emit a signal when its direction changes, and then the AI would receive that signal and it would update its like desired position based on that. So that's the sort of thing we could do with signals, so that we don't have to hard code relationships between different nodes. So anyway, back to the docs. Signals are a first-class type. We pass them around. We can create a scene. We can add a child node. We make a button. We connect to a signal. So we did this earlier, right? Where we double click. I might have right clicked and accessed the context menu and connected it to a receiver method. So what if I want to create a signal? Connecting a signal via code. Okay. Complete script. Okay, custom signals. Cool. And this is separate from what's above. Good. So we say signal and then the thing. Cool. Signals represent events that just occurred. We generally use an action verb in the past tense and their names, like health depleted. So we can have a signal that is player scored. Do we have separate signals for the player and the AI, or do we speak more generally? Is the logic different? Well, we've already implemented it, right? In goalpost, that's what we're going to move. We're going to move this detail about how to find the labels and keep track of the scores into scoreboard so that the goalpost collision detection stuff doesn't need to know about how the scoreboard works. And the scoreboard doesn't need to know anything about how we're detecting the ball entering the scoring area, the goalpost. I don't know. Two different signals is fine. Sure. So we define the signal here. And then we can emit. Or what makes more sense? The goalpost has the signal? Probably. Right, I think on second thought, the goalpost has the signal. Right? And the score lives in the scoreboard. Ooh. Reset timer? That's an interesting thought. We'll come back to that. Okay. And then what we do is we want to how do we yeah, you can declare arguments for the signal. To emit values, you emit, and then to receive them, we just hook them up, right? So what we want to do is we want to say func on player scored. Ooh, yeah. Let's do a reset game state. Func reset game state. It's not going to do anything yet because we need to figure out what we want to do. Okay, but what we're going to do for now is when the player scores, we want to do these things that we just cut. Well, on AI scored, really. Or on AI score. Score or scored. Also, because we are in the scoreboard, we can just use this path. Do we even need the quotes? Nope. And then in that case, let's be a little bit more direct. There we go. Yeah, we'll just do that. Cool. On player scored, do the same thing. And then we just change this logic to say this is the player scored emit. And if is player, right, then the goalpost is the player's goalpost, then the AI scored. Right? So now this is much simpler, right? And that's like all this node needs to know. And then all we need to do is in scoreboard. Sorry, now in goalpost. So in the player goalpost, we need to hook up AI scored to the scoreboard, and we pick on AI scored, connect. Cool. And then for AI goalpost, we want to hook up player scored to the scoreboard on player scored. It likes to take me to the script each time. So now this should behave the same way that it did before. So I'm going to let the AI get a point. And so the right number should increase. There we go. Cool. So that is the scoreboard. Let's also update our list of things to do here. So we're going to add acceleration next. And then we should add game continue reset. As in, once a score has been gained, like once the ball goes into one of the goalposts, the ball is re-added to the scene and the game can continue. So let's do acceleration. So we want to go into the ball, and we had a thing here where it was saying like we want to do this. So I guess all we really need to do is uncomment this line, right? So that's not quite right. What we want to do get the current speed of the ball. Yeah. Okay, so let me stop typing and start thinking. What we want to do is we want to say whenever we bounce, so we're here inside of this if, right? Whenever we bounce, we want to take the current speed of the ball and add our acceleration constant to it, right? So what we don't want to do with the code that I had commented and then just uncommented and then removed was code that would take the current direction of the ball, multiply it by the speed plus the acceleration, but that's not cumulative, right? Because we would always be in the direction adding a fixed amount. So what we want to do is we want to get the current speed, which is the length of the vector, and we want to add acceleration to it. So we want to increase the speed of the ball after a collision, right? So increase the speed by a factor of acceleration. Is acceleration a factor? I don't know. I don't know what this is going to do. So now that we have a new speed, we've taken the existing speed and added an amount of acceleration proportional to the amount of time since the last time we calculated this, Then we need to get the direction of the ball. So this is actually... Okay, yeah. So velocity normalized is the direction. To get direction. And multiply it by the new speed. Right? And that updates velocity again. So now, what we should see is every time the ball bounces, it gets faster. And hopefully by a reasonable amount. The AI movement looks really janky. Do we think the speed is increasing? Maybe. The amount of acceleration increase is constant. Like every time it bounces, it's increasing by a fixed amount. So it's going to get faster and faster, but the rate of increase of that is the same amount each time. So in that case, the acceleration value probably should be increased, or we might have to consider something else. Yeah, it's pretty subtle at this point. So let's increase the acceleration to 200. That might be too much. Do we believe that's what's happening right now? I don't know. It doesn't feel like it. Also, times delta doesn't make sense because we're not evaluating this per frame. This is only happening when there is a collision. So I think it should just be this. And factor is not true. Right, so this is just it's additive, not multiplicative. Yeah, so that is an appreciable speed increase. There we go. Yeah. All right. That's a little bit too much. Let's go to like maybe go back to 50 actually, so we have a few rounds before it gets out of hand. The other thing I could do is I could add another factor where we are changing the rate that we are adding. Oh boy. Oh. Oh no. Oh, and it's gone. All right, interesting. Probably some tuning there, but instead of working on like making this a fun game, let's just keep on coding things. So game, continue, and reset. How does that work? So when the ball enters, let's see, where did the goalpost go? So right now what we're doing is that we are capturing a score, but the ball doesn't get deleted or anything. It's still in the world, flying off. I guess the simplest thing, there are options, right? So one thing to do would be say, oh, okay, you know, we emit a score, and then we could, oh, don't autocomplete, stop it. We can do something like, we can grab the ball and reset its velocity and reposition it, or we can tell the ball to do that itself. I think a better strategy might be to, let's think about that. I think it's fine for now if we were to maybe call a method on the ball. Like if there's just a single ball object, and we're only calling it from one place, I don't know if it's even worth it to pursue like doing a signal. I think there is a question of like if we wanted to have multiple balls, or if we wanted to like delete the ball and recreate it. I think those things are related. Like if we wanted this like a scenario where there could be multiple balls flying around the screen, we probably would also want to delete them when they go off screen. But I think in the context of this, maybe we just want to do like, let's see, the goalpost I think is, yeah, so we could do that, or we could do like reset. And then we will make a new function called reset. And this is going to do these things. So here's the fun thing, right? So what we do is, I think it's the same code that we just took. Yep. So what we do is we have ready call reset. TBD if we want to actually always have it start at the center. It could start like, it should start midline, but it might start up or down. But this is fine. I guess the other thing we could do is, instead of it accelerating, no, it would be way too boring if it only accelerated after a score. Because I think at the slowest speed, I think it would be pretty shallow. I mean, we could start faster. And then another aspect of in thinking in that direction is like game difficulty, and then like having some kind of a difficulty setting that changed, like easy, medium, hard setting that then corresponded to, like, we can make resources that represented like what easy, medium, and hard meant in terms of like initial speed and acceleration and like strategy for the AI player and those sorts of things. But yeah, anyway, so we'll grab the ball and call reset on it, and that should get us back into a place where we can continue the game. So and I think after this we need to figure out why the thing, why the AI player paddle movement is so janky. But why did this happen? So in goalpost, we tried to call reset on a null instance. So could we not, we didn't find the ball. So the goalpost script is attached to both of these that are in main. I guess we have to do .. / ball. Okay, maybe that'll work. Maybe there are things that are a reset method. Hopefully we're not overriding something important, but let's stop and restart and see if we can get this to work. I'll just let it win. There we go. Can I beat the AI? I'm not holding out a lot of hope. Aha, I did. Wow, okay. I defeated the computer. And this continues forever, right? We don't have a place where the game ends, nor a way to stop the game other than... So I think The handicap for the AI player is just that it's limited on how fast it can go. So it has a limit on how fast it can attempt to follow the ball, and because it is just naively following the y coordinate of the ball, it's not predicting where the ball is going to go. But good, that gives me a hope of winning. So why is the AI? So we did a game that was easy actually. Continuation and reset. Let's see. Debug AI movement. And then what else? What else can we do? What else was on our list of things? Let me get my hand tool. Okay, so I wanted to practice navigating to the 2D editor, snapping and grouping. We looked at that a little bit, learned the basics of instancing scenes and saving reusable scenes. I've not done that yet. We ended up not pursuing having the ball as something that we would instance. In fact, there's nothing really, everything is persistent in the scene and is reused. Nothing is like removed and added or added multiple times or anything. So that'll be something we'll have to experiment with for the next thing. In fact, do I have to go into the text tool to edit this? Nope. Yeah. Later. Paddle movement. Try implementing a simple Node 2D that moves based on Node 2D that moves based on input. We ended up using the character body 2D for the paddle as well. Adjust movement speed and has clamping on screen bound. So we didn't end up needing to do that. There is a nice clamp function you can use where you can say, hey, constrain the result of a value. So like a calculation to be between two values. But we didn't end up needing that because the fact that we have those static bodies at the top and the bottom of the screen constrain the paddle. Ball movement and bouncing, yeah, we did that. Initial velocity, move and collide, learn how to respond to collisions, and experiment with custom bounce behavior. Oh, we've not done this. So have the ball angle depend on where it hits the paddle. So have angle of bounce vary based on where on paddle collision occurred. I think that'll be fun. I might tune down the acceleration for the ball. I'll do like maybe 20. Give us a little more time to get used to things. So that's the kind of the list of things that I wanted to practice in terms of like things in Godot. And then I had a bunch of features that I wanted to explore, some of which we've done. So we've touched on signals, collision bounce, inertia. So one thing, so many things we've done already. We still have a little bit of time today. I feel like these might end up being mutually exclusive. So the idea is like, the idea for this one is that based on where the ball hits the paddle, it bounces off at a different angle, which doesn't really make sense if it's a flat paddle. but you know, it's a representation of a real life thing in a video game. The other thought was inertia. Maybe they're not mutually exclusive. Now that I'm saying this out loud, is that when you move the paddle up or down, it can drag the ball more or less in that direction. Right? So if you move the paddle to where the ball's going to go, and it's stopped, and the ball hits it and bounces, it just like it is reflected off at an angle that is kind of the reflection across the, you know, it bounces. What more is there to say? But if the paddle is moving in a direction when the ball hits it, should that change the direction the ball bounces off? Right, you impart momentum. Also, this is not how you spell inertia. And is it inertia or momentum? I don't know. I don't have a physics degree. Okay, so we can do that, but first I want to figure out why the AI is behaving the way that it's behaving. So, let's see. In our physics process, we get the current position of the ball. We figure out how far our Y position is from the ball's position. If it's less than close enough, maybe close enough is too big. How often is it close enough and how often is it not close enough? Right? Because if it's close enough, we move towards, moves from Y to 0 in an increment of speed. So if it's close enough, we take our existing velocity, we subtract speed, as long as that doesn't take us below 0. If it takes us below 0, we just set the velocity to 0. So we slow down, in other words. Wait, is this right? Y towards... Yeah, because it's velocity. It's not position, it's velocity. Right? So we have some existing velocity coming into this from the last time we processed, and if we're close enough, we decrease our velocity to 0. If otherwise, if we're not close enough, we figure out which direction we want to go in. We multiply that by speed, and that becomes our new velocity. So versus what the player does. When we input, we have an axis, and this direction is a float. Right? Get axis returns a number between 0 and 1, right? Can I control click on that? Nice. Yeah, so the get action strength is between 0 and 1. Okay, cool. So this number will be between -1 and +1, which means the player's velocity will never exceed 400. So the AI should be able to move at the same rate the player is. Maybe close enough is too big. Let's bring this down to like 5. Let's see if that makes the AI not look so janky. Okay, interesting. So yeah, we don't have momentum there. Which does end up making this kind of boring, right? Because we can't influence the direction of the ball at all. It's just doing whatever it's doing. All right, so 5, huh? What if I made it like 1? Does that make the movement less or more smooth? Interesting. What if I... So, go back to 5. I think the challenge with the first test was that the direction of the... Okay, that seems fine. I mean, just overall, like, the AI behavior is not great because it shouldn't be tracking the ball when the ball is moving away from it, unless it's going to be like, oh, I know the ball is going to go here and it's going to go there, but it doesn't really know, because especially if we make it so that the direction of the ball is determined by where on the pedal it hits and other things the player inputs, then it's going to be harder to predict. And there's no prediction happening right now. Nope. I guess one thing that's happening right now is if the ball hits the end of the paddle, it definitely goes off in a different direction. So how would we make it so that when the ball hits a different portion of the paddle, it bounces a different way? Right? So if we pursue having angle of bounce vary based on where the paddle collision occurred. To do that, that's happening inside a ball, right? We're saying, hey, if there's a collision, we get the normal of the collision. So this is the unit vector direction of the thing that collided with us. So the direction it was going. And then we say velocity.bounce returns the vector bounced off from a line defined by the given normal param in perpendicular to the line. Bounce performs the operation that most engines of framework call reflect. Got some additional stuff in there. Interesting. Okay, so collision is the kinematic collision 2D, and get normal returns the colliding body's shapes normal at the point of the collision. In this context, oh right, okay, so the point of collision is where the ball hits the paddle or the wall. The normal is essentially like if we're hitting, let's see, how do I frame this? If this is the paddle and the ball's coming in this way and it hits this surface, then the normal of the surface is a vector that goes this way. And so we want to reflect the angle of the ball as it hits the paddle across the normal to the other way, so going this way, right? That's what's happening. But what we want to do is we want to alter that vector coming off based on where on the paddle the bounce happened. And I have no idea how to do that, but maybe change the direction of the bounce based on the distance in the center of the paddle. So of the thing hit. Okay. Let's give us some space here. So hit position, collision dot position. Hit normal. Okay, collision dot get normal. So this is again that the vector perpendicular to the face that we collided against. The center is... Do I believe any of this? So position is our position plus velocity normalized. So that's kind of the direction we were going. Except it's velocity normalized times collision, get remainder divided. Okay. So it's like, where do we hit? And that might even work. So get remainder returns the moving object's remaining movement vector. Here's a question. Is there not a way... Just hold that thought for a second. Collision dot... So we can get collider shape, shape index, velocity. I'm just wondering if there's a way to get the point that we collided at. And maybe I should look at what position is, because maybe that's that. Obviously, I mean, Copilot's really great for this because it gives me a lot of like, oh, maybe you could try this, maybe you could try this, like hints and stuff. Can't really trust it, and it's not going to be helpful for me to learn if I don't actually dig into what things do. So let's see here. So collision.position. So move and collide returns a kinematic collision 2D. Okay, can I look at the definition of move and collide and look at what a kinematic collision 2D is? There we go. So kinematic collision 2D has some methods like get angle, get normal, get position. So get position returns the point of collision in global coordinates. So where do we collide? So I might want that. Okay, we're already using get normal. There was something else that was that looked interesting. Get angle returns the collision angle according to up direction. Its value is always positive. Sure, maybe not. Let's get the position. Get position is collision dot get position. Position. There we go. Okay. So it's trying to... I don't think I want to do that. Essentially what I want to say is... Oh, I mean, we get the right. So we get where the collision happened. And we get the normal. But center doesn't really make any sense. What we really want to know is collision dot get collider dot. I don't know if there's a good way to say, hey, oh, maybe just the global position. If we get the global position, we can say how far we are away from its center, and that should be a proxy, right? Global, hold on, var target colon equals, okay, so do we believe this nonsense? Or is it nonsense? This is the question, right? So target center is target.position. That might be a thing. I guess if we're only using it in one place, let's move this down here. Okay, hit position is a vector. Let's also, like, we can do this, and we know what the type is. It's a vector too, yeah? And hit normal is a vector too. Position is probably a vector too, and so we're getting the difference between these two vectors that are positions, and we're getting the length of the difference, which should be the distance between those 2 points, right? In an absolute value. Yeah. The bounce angle to, I believe, this. Target, get size. What is target here? Target is whatever get collide or returned. It's something. Get size length. I question whether or not the thing in question will have a size to have a length. And I don't see what the relation is between that and distance from center. I think what we should do is we should say, oh, I get it, right? Because what we want to do is we want to say, how far are we from the center? What is the total? How far could we be away? So what is the proportion, right? So if we are at the center, if it's a really small number, then we have, okay, and then bounce angle. So we end up with pi over 4 times hit normal dot x. What does it mean? Do we want to just try this and see what this does? I think I might have to go find an example somewhere. Yeah, there's no get size for static body 2D. And it's not always going to be a static body 2D either. What if we, let's just set this to 0, and we're going to print this value. Right, so that should only happen. Interesting. It just is dependent on how close. Yeah, 7, 22. Interesting. They're very close to center, right? But it's relative. And I guess the other thing is that this effect should only happen for the paddles. In fact, could I do something clever here? Where I can ask if the object in question has a method and have it calculate what the bounce is. So we do away with all of this, and what we say is if target. Can we ask if something has a method? Yeah. And we pass it the ball. We just give it the ball. And so it would be able to modify. We've already done the initial bounce. So if the target that we collided with has logic, it can do things to us, right? So now I think what I want to do is I want to create a new GD script, right? That is like a base class used by both the AI and the player. In fact, yeah. Yeah. Okay, so let's hide this for a second. Let's create a new file. This is gonna be paddle.gd. And this extends character body 2D class. Do I have to paddle? Yeah, and then it's basically we're gonna have a function called on ball collision that is gonna take a node. I guess technically, can I do this? Can I just say it's gonna be a ball? This would turn void. Yeah, but we haven't defined that because we need to say, hey, this thing that extends character body ID is a ball. Can I do that? Maybe, maybe not. Let's just go back to it being a node for the moment. We'll figure out what we're doing. And then what I want to say is that player doesn't extend character body 2D, it extends paddle. Right? And then we get rid of, or rather we take, yeah, why? Oh, we probably need to add paddle to the project. That's what we're missing. Can I go forward? Oh no, I already. Let's assume that I can make this all work, and we'll say that the type here will be ball, and then AI we also want to extend paddle, and we'll have a speed constant that we'll get from what we inherit. Okay, so yeah, parse errors. Sure. We have a paddle.gd now. Okay. Ball.gd. Yeah, we're defining this. Can we not refer to this type? What am I missing? What if I just call this node? Okay. But we still can't find base class paddle here. Okay, Googling time. Actually, maybe I have a link. What are Godot classes? There we go. How scripts work. Godot's internal classes have methods that register a class's data with class DB. Even scripts that don't use the extends keyword implicitly inherit from the engine's base ref counted class. Attaching a script to your object. What if I have a script that's like a base class? Okay. Could not find base class. Let's try some Googling really quick. Godot cannot find base class. How do I create a base class? As soon as on a class, I know. Class inherited nodes can't see parent class method. It thinks it's defined here. We even give it a name. Is there something else that I'm supposed to do to make this work? You know, Ooh, fancy. Maybe. I mean, I do want to do that. I feel like I'm missing something important here. I just don't see what. Oh, now it's fine? Okay. Right, so we're exporting some variables. That means that in the game engine, like when we look at the player, go back to the inspector, oh, we haven't gotten that far yet. We need to update player. Yeah. So speed becomes speed, and speed becomes speed. Oh, and then everything works. Okay, cool. But yeah, there we go. So now the player that has this player GD script attached now has the speed and acceleration. So that means that in the inspector, I can change these values without having to go into the script, which is a benefit. The main thing I was trying to do, of course, was to implement this on ball collision function so that we can implement the idea of having the angle of bounce change, right? And we only wanted to implement that for paddle. So yeah, we're done with. We don't need to change goalposts. We don't need to change scoreboard anymore. We do need to implement this. But yeah, so by doing this, we essentially don't have to worry about changing anything here again. Here's a question. So we have this class. Can I say, hey, this is a ball? Yes, I can do that now. So whatever I was doing wrong, maybe I just needed to add an export. Maybe it just took some time for the things to settle out. I don't know, but it's working now. So now we should be able to like, hey, print ball clay with paddle. So if we run this really quick, we're gonna see some stuff happen. Yeah, ball clay with paddle. And when it bounces off the wall, we don't get such a message, of course, because the target of the collision was not something that implemented that method. So what we should be able to do in that method is use what we know about the paddle to change the direction the ball bounces. I think another thing we could do here is, yeah, let's just say we want to do both of those things. The other thing we want to do is we want to have a timer on screen before the ball spawns. Okay. So those will be things that we will pick up next stream. Sadly, I can really only do one of these coding streams a week. So next Sunday, we're going to pick up where we left off here. And then there's a lot more to do just within this game, right? Because there is a lot of like general stuff I want to figure out about doing in Godot. Let me move this over to the side so it's actually not hidden by the keyboard. So hey, there's some stuff that I just wrote down. We had scores, bounce acceleration, but having a splash screen when the game starts, having a start menu, a pause menu, being able to like configure keys, credits will be very abbreviated at the moment. So there are some like general things to figure out that'll be applicable to future little game projects. There will be things beyond Pong as well. It may take a stream or two to get there, of doing, I don't know, some kind of like breakout clone or a Tetris clone or, you know, what have you. Just various things, various, you know, more and more complex game projects to kind of stretch out, to motivate, shall we say, practice with Godot and learning all about this. So what we're gonna do is I'm gonna first of all say thank you so much for coming out to the stream today, for being here, whether you were here for a little while or the whole stream. It's appreciated. It's nice to have some company. And we're gonna go find someone to raise.